I can get a little sense of which direction I should go. Maybe ask, how many of you consider yourself very technical engineering background versus like in finance and others? Like technical, maybe raise your hands. Okay, so all of us, that's good. My talk was prepared for 45 minutes, then I realized it's only 30 minutes, so I'm going to try cover everything. In the very end, there is some case studies that we could cut some of those. Maybe that would be a way to cut time if I ran out of it, but I will try. Okay, so just a quick word about myself. Wenjing Chu, I'm a Senior Director for Technology Strategy at Futurewei. Internal job function is to drive strategy for Metaverse, Web3, and trust. So everything sort of all together. And in that capacity, I've been involved with a lot of open source projects. I'm currently working with a group of companies trying to start an Open Wallet Foundation. There was a mention earlier by Gabriel. It's going to be based on Europe, so he's very much involved. I'm also in the steering committee for Trust over IP. It's another Linux Foundation project working on specifications for trust and trust architectures, etc. And W3C, so the World Wide Web, so you're probably all familiar with. So with that background, I will probably get started. We're going to talk about the architecture. And really, it's three things. One is a general purpose open source digital wallet. And I think a lot of the time I want to emphasize the first phrase, general purpose. The second one is universal interoperability. And what does that mean, why it's very important. And then finally, we can talk about how to achieve that as an architecture. And there are a few case studies, like if we have time, we'll go through those as well. And I hope to get your feedbacks, opinions, and potentially interest and involvement. So that will be my purpose of this talk. I'm going to start with the general purpose portion of it. And so there's a so-called specialized, and we're using crypto as a example because a lot of people automatically start thinking about that. But so I list a bunch of them, but this is I'm not super familiar with it, but there are a lot of different wallets out there. And there are many different types. People talk about whether you have custody or it's actually a proxy to another account. And you can even imagine whether the money is actually in your wallet, right? Stuff like that. But the way I think of it as a specialized is that it's only for this particular purpose. Versus on the right, I'm using this Wikipedia picture for iPhone. You have essentially a container for lots of stuff. And these are digital assets. This can be money, can be cards, passes, and IDs, and can be essentially anything. Like, why not? Right? Anything that you feel important enough, you want to be there. You want to have a very personal control of it. So think about it. Yeah, it seems like it will make sense to have a general purpose one. But the other way to look at it is this crypto wallet special at all? So I copied this from, I think it's like a tutorial from Money Magazine, right? It's for layman's terms. But essentially, what is this wallet anyway? It is just a place to keep your secure code. Or if you fancy, you can say, well, it's the owner's identity and account. It's just a UI so that you can reach an account which is actually elsewhere, not in your wallet. And if you think of that way, then it's no different from like my bank app, which is basically a little app which allow me to log in, get authenticated, which allow me then to access an account actually not sitting on my phone, but in some bank's infrastructure. So in that case, this crypto wallet is no different. Is that I think most of them are very badly designed, and therefore there's a lot of trouble with it. So the other concept want to shift to then is this proprietary or closed versus open source and open standard. And I think in this country, we're familiar with iOS and Android, all have this concept of a roughly general purpose wallets. And so there's a lot of companies really want to see see the need for a open source implementation of a wallet, but also that such a wallet are based on open standards. So this openness, so if you think about like a credit card, right? You have Visa, which is in a way a consortium, and which bank offers the card doesn't really matter in terms of openness or interoperability, as long as it's Visa. And so in the similar concept can be applied for any other asset, which some organization or some industry may define a standard, and as long as all the parties use that same standards, then that will be interoperable. In addition to that, the wallet itself, for a general purpose wallet, we may want to standardize how it behaves so that any person can access or interact with that wallet or build that into their applications without essentially have a gatekeeper. So we will have a standard type of wallet. The gatekeeper is all of us rather than two giant corporations. So that would be another purpose, I think, to achieve all of this. And I think it's a very important and very timely thing that we think about this. So to summarize, I think that digital wallet is a very critical piece of technology. And we need to ensure its openness and the level playing field and with interoperability. So that is based on open standard and open source that can solve a lot of problems that we don't have to reinvent all these solutions in different industries, right? So you can think about, someone like a DMV issuing a driver license versus a bank, want to connect with their consumer and access their accounts, or a crypto, or a university want to issue a diploma. Why do we need all these different verticals to come up with a solution again and again? So that's the concept. I will say a little bit about the Open Wallet Foundation. It's still being formed, not formally launched yet. So this is the press release back in September when really the discussions and preparation started. We hope to be able to announce the formal launch pretty soon. And there's some of I think the key words here about the mission, why we're doing this, right? And naturally, we are talking about wallet very loosely. Strictly speaking, this would not be exactly a wallet, but a engine or that for someone to build a wallet. But this wallet, it doesn't matter which one built into their product, they will all be based on the same sets of standards and be interoperable. So, so you have a wallet that different kind of cards can be, or different kind of asset can be added into it, and the asset will behave based on whatever that particular vertical standardization says, it should be. So anyway, so that's the concept. And there are some examples of these assets we're talking about. Again, these are currently, because the foundation hasn't really been set up yet, all of these are simply early discussions, and there's a lot of people who are interested in payment tokenization based on EMV, and so that, naturally the credit card companies are interested in that. I also, MDL is the mobile driver license. I think there are 3 US states already supporting it. The W3C verifiable credential is a decentralized way to do credentials. So the verifiable credential is really, even though they use credential, it's basically data that's verifiable. So you define any kind of data you want, and the verifiable simply means that you can independently, without reaching out to a centralized server, to be able to verify the data's validity and, well, I should say authenticity of that. Anonymous credentials are another type of credential that allow people to do zero knowledge proof. So you can do selective disclosure, sometimes even combine information together, and so that's give you a lot of privacy control to the consumer. Underneath here are many of the related, organizations either work on specification or open source. So I would probably skip the introduction of all those to save some time. So the question comes to how do we achieve universal interoperability? Now, I'm going to jump into more engineering talk. Trying to maybe walk back about the internet principle or the architecture of the internet. There are many ways to summarize this, but for today's talk, I'm going to talk about protocol and layering. You may also hear so-called end-to-end principle or hourglass architecture or universal reachability. Basically, in the very beginning of the internet, actually internet was a small rebel against many much better funded and established alternatives. But internet in the end won because it followed a very simple idea, which is to make sure that we maximize reachability, or we want to be able to allow internet protocol to be supported in almost any devices with the minimum effort. So it naturally does the least. It has very minimum functionality, very little, but trying to create this network effect. Right now we are talking, it's a very common idea now, but at the time was very revolutionary, and it was proved very successful. So we, unfortunately, in that minimum set of functionality in the internet, the authenticity, or some people will call security, is not one of them. They are not in it. And so we've been trying to sort of live with that decision ever since. And we are trying to, again, propose a new architecture which will add the authenticity or security of it, but without, with the same kind of universal accessibility, right? So we want to make sure any device and with the minimum set necessary to achieve trust, and then use different layers or higher layers to add new functionality on top of it. Okay, so this is a very common picture. People start with, you know, this dog cartoon. And so I have a very general purpose picture with two entities interacting with each other through technology, right? And you know, if the Bob on the right side receive a message like this, what do you do with it? How can you trust it? What do you trust? What does it even mean trusting it, right? All that issues, and so it's a very complex issue, but it's the picture itself is relatively simple. And we, you know, through many, I think, organizations and studies, we found out that foundation requirement itself to solve this problem is actually pretty simple. We use the word authenticity, which is to mean a authentic identification, knowing the source, or we can say knowing who you are talking to, right? That can be divided into two components. One is a verifiable unique identifier. So that eventually becomes your ID. And the other one is some autonomy on your computer. Autonomy or some control over your environment. And with these two, you can achieve authenticity. So this whole set of quite mature algorithms allow you to achieve authenticity with, you know, relatively minimum amount of effort and using very mature algorithms and crypto protocols. Without going into too much of a detail, I would make a claim that this is necessary, but it's also largely sufficient. So we found this minimum set that can be the foundation of universal trust over internet. And all the other features we can actually can be built on top of this foundation. And this whole set of minimum features are simple enough that we believe all devices on the internet today can support them. So that goes down to, like, I think this is one of the earlier sessions talking about low-cost feature phones, or, you know, at least low-cost smartphones can support these. IoT devices, smaller battery-run devices can support this. So we want to really be able to go achieve a universal reachability for this. Okay. So as we walk up, as you know, before we jump on that, there's a way of sort of like how do we actually support these, and I'm going to use the autonomous DID. DID is a phrase that W3C uses for decentralized identifier. I like it, but the concept of saying if you replace a different ID, you would need to essentially achieve the same kind of resolution and functionality for your ID. But I'm going to use the DID as an example here. And there's multiple ways you can actually have a system to support these kind of a setup. And on the left, you know, it's our current system. So you are either on a centralized identity system today or a federated system like OpenID, for example. Or you can have a decentralized system like what the DID wants to do. There are other examples like Web3, or some people call Web5 now, of quite similar. And there's another class, people tend to use the word web of trust, which are sort of about some peer systems. There's a set of algorithm called autonomic, which, you know, is even stronger in the decentralization, or allow the individual to make decisions. But all of these can support the same authenticity requirement we propose here. And therefore, you have an identifier, and you have authenticity guaranteed. All we need is a little simple protocol between them. And so that we call it a trust spanning protocol. And so this protocol is very much similar to like an IP protocol. You can think of DID as a IP address, and this protocol simply talk very simple based on that address. And they are fully authentic messages between them. So pretty straightforward. The protocol was only need to support asynchronous messaging. It doesn't really need too complicated. And especially if you, because we don't need to add too much functionality on top of it, in this particular layer, the messages you need to send are pretty simple. So you can have a very authentic messaging layer, quite common. And then, I think we can start to talk about interesting stuff. Then you can do identities, you can do credential, do authentication, authorization, payment, money, crypto. All that can go in. A lot of people are interested in doing authentic media, like, how do we make sure photos are not doctors, how do we solve fake news problems, stuff like that can all go in, right? And in general, it's really any kind of data. So the only difference is how do you define these data, what kind of data you define. And I know in earlier sessions, there's a lot of data model defined in the financial industry, and you can just plug in and this whole set works for you. Okay, so just a quick summary. These will be the proposals we have in mind of this 4-layer structure. And it's, again, very, very similar if you look at old, like a TCP/IP stack, how it look like. The ideas, philosophy are very similar. And I think that will help us to not only solve these problems, but solving it in a very principled way so they are universal applicable. So we don't have to reinvent the same stack again and again. And so that's the idea. Okay. Okay, so I'll probably skip a little of that slide, but then come back to the wallet, right? What are we talking about the wallet? So wallet comes in, maybe we are directly doing this on the phone, but a more general purpose scenario is where the wallet is really the connection, the 3-party connection between a computing device, a wallet, and the person. And so the wallet helps to bridge the gap of, a person have a convenient and interface to manage these sensitive data. Not only you have, more likely to have physical possession of it, but also give you a relatively convenient interface so you can actually start to do actions on it, manipulate and do, signatures, approve things, send money, right? So it solves multiple problems there. And again, this tied down to the rest of the architecture. Okay, so this is just a quick summary. I think we don't have to repeat them again here. And so the more sophisticated features, and many of them already have mature protocols. I just don't have time to go into it. But those features can be built on this basic authenticity layer. And then, I like to think of them as reusable trust tasks. And the task pattern itself actually, like a transaction, it's really can be abstracted, not necessarily require a goods to be exchanged and payment, etc., but can be abstracted and be applied and used in other industries too. So those are reusable trust tasks that's built on top of this layer. And the good news is that most of the implementations that we've studied today already support it. They do need some kind of refactoring out of for modularity. So typically, this layering already exists in some fashion, but it's not very principled. The interfaces are not clean, right? And so some refactoring are required in many of these implementations. And therefore, we need to sort of sit together and agree on exactly where. In principle, they all can support them. The layer is already in place, but the exact details of that need to be worked out, and so they need to be then conform to a common, I should say, set of common standards. And by that, some of the standards, as you see, already exist as well. So let me see. I think my time is still okay. Yeah, I still have some time. So I'm going to go through some implementation examples on this. So the current state is these either central or federated systems, OpenID, FIDO, and the fundamental setting in these kind of systems is that you have a server. So this is shown as a server. Whether it's web or, doesn't matter what kind of server. The server has a certificate, has a CA issued a certificate, and can be identified using, quite good asymmetric identification systems. And you can sign stuff, and there's a lot of things happening. But the user doesn't. The other side is not. So they are not what we would call peer-to-peer, or they're not decentralized, because you have one entity is clearly have a lot more resources than the other. In this system, I think the classic one will use ID and password, and ID and password would show up as a data entry in some kind of database in the server, which is not very secure. And I hope I don't have to preach that, but there's tons of problems with all these setup. The federation model allows some kind of a slight improvement. So in this case, you introduce a provider, like people commonly use, maybe like I use Gmail, which then act as you will have an authentication, of course, so you log into this particular service, and then you authorize this service on your behalf to go log in here, and also authorize them to release your user information. And that's an improvement, but it's not a huge one, I would say. And the cost of doing this is that then you release your user information not only to the person you are talking to, but you also release that to the middleman as well. And the middleman happen to know a lot. And so it is, to me, like a not very private arrangement. Within this scheme, you can introduce things like FIDO, which allow you to do mobile as well. So the user may feel like you are already doing all of this. So you can do your login, authorization, everything on the mobile phone that binds those three units together. But still, back behind the scenes, your information are still going to some big aggregator. This will be the first example of decentralization. So this is happened to be based on a Hyperledger project called Aries and Indy. So in this case, you have a wallet, and it doesn't have to be this particular kind of blockchain or even blockchain at all. It's just some kind of database are needed there. And then this would allow the two sides to establish a relationship. So it's like a personal relationship. You only need to authenticate them once. Once you are known, you exchange your keys, and in a way, you are known forever. You know a way to authenticate that as long as, until your next key rotation. So it is well defined, and you only need to reach this database or blockchain once in a while. I don't know, maybe nowadays 6 months, 3 months would be sufficient for key rotation, but even those rotations are automated anyway. So most of the time, you now have a very secure channel point peer-to-peer. And again, you can see from the picture clearly, the two pictures are completely symmetric, right? The two sides are symmetric. So that allows the very secure channel between these wallets and be able to actually establish trust and then build much more sophisticated functionality on top. There's another example this is from Block. So they are doing digital payments and also sort of a crypto to money exchanges between them too. And so one of these things, people would think about it is KYC, right? And so like a verifiable credential would be a perfect idea of a KYC requirement because it essentially checks all the ID you want, whatever the law says you need to check, and these IDs are based on a digital verifiable credential, and the credential can be established so that the customer can be essentially validated or as much as whatever the regulation needs. So this clearly with a DID and verified credentials and an IPFS-based replication system, these give you a pure, I guess, Web3 or peer-to-peer way of doing the transactions and can be fully compliant with any regulation we have today. The last one is the most, so this is sometimes called autonomic, but basically this will be a purely web of trust model. Again, this, I don't have, really time to do justice to this, but you have, instead of people think of a blockchain, right, need to be in one place. Here, you only need a so-called witness, sometimes friends, for example, in some of the social media systems, you can do that. If you forgot your password, you can pre-designate a few friends, which will be able to then vouch for you to recover, for example. And so it's a very similar idea, just designed with a more rigorous protocol behind it. Okay, so hopefully I convince you that there's a lot of work going on. Many of these implementations, I think all of them are open source, other than the first one, of course. And then they essentially follow very similar model. And so within the Open Wallet Foundation and some of the Trust over IP as well that I'm being involved with, believe that the whole industry can come together and really follow a more rigorous structural model in these layers that allow us to basically have this benefit to any device on the internet. Any industry doesn't have to be in finance, doesn't have to be in any, we think of you need a security. I think authenticity, if you think of it, I need it all the time. I want to be sure who I'm talking to. And so that's our proposal. And I will quickly summarize the key takeaways. I think digital wallets is very, very critical as an infrastructure, and we should make sure it's open. So we give everybody a level playing field. It's not overly centralized into a few small number of companies. And I think we can achieve all of this by a architecture very similar to TCP/IP. So I call the trust task layer / TSL would be the trust spanning layer, similar to that nature. And so you have a very specific trust tasks, and these tasks are built on top of a common and minimum trust spanning layer. And so we think that's the good way or good path towards this universal interoperability for wallets. I would invite everyone to get involved, and I want to hear what do you want to see as a priority for Open Wallet, and for that I'm open for anyone's suggestions and comments and questions. I'll leave some additional information you really want to dig down deeper. Here's one is the specification. The other two are videos of the deeper talks that I've given in the past. Yes, any comments or questions or opinions?
So some of things you touched upon, so now we see that the password less authentication, no password.
Yeah.
So how that is also under the
Yeah, so whether it's centralized or decentralized, fundamentally is look at whether the two party has a symmetric or asymmetric relationship. So there are many ways you can avoid the password, which is nice, I think. It's very convenient for us, but without fundamentally changing the underneath protocol, you don't really change the issue there, right? You do improve because I would not have to pick bad passwords. I don't have to write down. It will improve, right? I'm not saying those are not significant, but they don't fundamentally change the the real situation here. So we believe that both sides need to have strong authenticity guarantees that allows all of us to have trust. Therefore, we don't need to rely on a giant third party to vouch for us, right? That's,
exactly,
yeah.
exactly. And the reason I ask, I mean, Microsoft, all the big tech companies.
Yeah, yeah.
I mean, I see that some of the concern of open source, a better way of doing things, but the industry is moving. So,
Yeah.
what is that adoption? Is it a big guys are supporting?
Yeah, so there are you may notice that Open Water Foundation is going to be created in Europe because European Union are legally mandating a Europe-wide identification. And so the EU ID, it is, I think, to be launched next year. And that would create a very big marketplace for all of this. So naturally, many of the EU services are tied to these IDs. So that includes like, medical, travel, and between all the financial services, telecom between EU countries. And so that's one big incentive. And you probably hear a lot of like cross-border problems, right? Because each one's different. And that's another reason we need this kind of interoperability. There's numerous similar drivers in US as well. And so a lot of these adoption, I think, currently are in the niche market, in niche areas. But I think we should aim bigger. Aiming bigger is not to delay this thing, but to really see the snowball rolling. Because a small area usage does not, it's a lot of cost to implement a new scheme. But if you're only looking at one slice of the market, it may not be big enough. People may not want to, But once you look at a larger scope, then I think it will have a much stronger incentive for people to do this.
Exactly. It does help with data privacy too.
Correct. Yes. And so this, yeah.
Protocol address.
Yeah.
How do you recover?
Yeah. Sure, yeah. So losing the device or how do you recover, etc. So you like in iOS, they have a iCloud backup, right? Yeah. And the key is really you do the backup. The key is how do you hold the key yourself. So in the end, you can see that you will need some kind of a web of trust solution if you don't want to ask Apple to hold the key for you, right? So those are all quite related. Now, even if you hold a key for you, there are schemes that you can say, well, you can just recover one key for me. not really the data itself, because from there you can then recover the rest of it. And so that is also possible. Basically minimize the amount of information you have to share. The keyword is really, currently you have no option. Yeah. Correct. Yeah, the protocol all exists today too, so that you don't have to at all. But the user convenience is a critical problem. And I think one of the early work for Open Wallet Foundation is to we call user experience, how we can interact with this system, right? That's critical, yeah. Yeah, so there's so if you lost your phone, the current setup, because this require your some kind of a biometric authentication for your, so a similar kind of system exists to the wallet you would have in your iPhone or Android phone today. So that requires either a physical biometric mechanism, or it is a time-delayed lockup mechanism, so you can immediately lock it up for you, so that data is not released that way. And there's quite a lot of new work being done today. Some are very futuristic with AIs, and you potentially can do more and more get to that. But yes, that's one way you can lock this up more. And the other is related to an earlier question about, because there's always a cloud backup copy somewhere. And when these two things happen, it's not exactly clear yet. So I'm not claiming these are all perfect solutions yet, but that's still to be worked out.
Owned by Huawei?
Yes. Okay. Do you have a question?
No, that was my question.
Oh, yes, it is. So we are a R&D division or subsidiary in US. We are relatively small, I think now under 400 people. Most of us work on standards, open source, and ecosystems. So we don't have developers or product groups here. Part of the reason that we strongly support this kind of system is because we want to see an ecosystem that allow people to compete openly. So we're not tied to a particular, because right now in Android, the Android system require you to sign contracts, right? Instead of a protocol like a TCP/IP protocol or HTTP protocol, you can define an API and have open access to it. And that's the big difference. This is true not just for us, for any licensee or other, or the Android-based phone manufacturing companies and other devices too. So any times we get into the apps, you probably hear a lot of the apps want to do payment in-app, but you may be required to use Apple Pay, all those things are locked up because it's not a standard-based system. Not in this space, because the issues we deal with are universal. It's for, so all the companies involved do have very concrete and similar concerns. The European Union, as I mentioned, and many countries in UK, in Canada, and many states in US as well have similar issues. And so it is in high level, it is I think one is a access issue, whether you have an open standard for whether it's competitor or you're actually your own customer too, right? Where they can innovate and build a product around. And the other is related to these silos, because the silos just slow everybody down. And so both of the issues show up in all the regions. And at the moment, the area that's pushing harder than others, I think, is in European Union. So, so that's why I think a lot of these initiatives are being driven there, and that's why we started this foundation in European Union.
Looking to, obviously, you're coming up with a protocol to establish.
Yeah.
What about, are you as well that implement that protocol?
Mm-hmm.
Or are you going to leave it open to
others? So whatever I present today is my view how this could be done. I think we believe this is the right way to go. The foundation hasn't even been established yet, so I cannot represent, you know, the foundation itself naturally, or any other company that may have, you know, other solutions as well, right? But hopefully, you know, the message is quite clear. We have no issues. We have a lot of people who want solutions. And so we are working on, as part of a bigger community, on how to reach the most optimal solution. And this, you know, this is a proposal from us of considering a lot of these. If you look at the specification document, is actually coming out of a trust over IP. So that's another Linux Foundation group that's writing specifications. Many organizations involved. We're just one member in that organization. And so these are very, I think, well-known and studied approaches. They're not exclusive, naturally. There's a lot of different ways you can do this. Any other questions? Not? Thank you very much. Come find me.